Okay, so let's take a look at multiplying rational expressions. This is multiplying fractions. The same rules that you learned in elementary school for multiplying fractions will still be the rules that we abide by here. Okay, so let's take a look at how it's going to work. When we multiply rational expressions in algebra, we do it just like you did if you did canceling from elementary and middle school. By canceling, I mean you found common factors between the numerator and the denominator, and you divided them out. You might have called them canceling out, but you realized that any number over itself was a 1, and so it kind of almost magically disappeared. We're going to do that same thing now. We're going to factor all numerators and denominators completely. Then we're going to divide the common factors out, making 1s. Then we're going to multiply the remaining ones back together. Let's start with an example that is almost numerical, and I'm going to start by telling you the part that most students are going to miss. I'm going to write it up here in a red pen. You had better remember to tell me that all of this only works if y is not 0. Because if he is, right here before the problem ever began, you divided by 0 and violated the first commandment of algebra. So be sure that you include that somewhere with your answers. Okay, since this one is kind of like middle school, except for the y's, and we'll get to them in a minute, I'm going to cancel like I would in middle school math. 2 goes into 2 one time, 2 goes into 8 4 times. 9 goes into 9 one time, 9 goes into 27 3 times. So numerically, this works out to be 3/4. But I haven't dealt with the y's yet. Okay? So now I'm going to deal with the y's. And there are 2 ways of looking at it. Whichever way works best for you is great with me. But I'm lazy, so a lot of times I just say, well, those 2 y's, cancel out 2 of those, leaving 3, and that's in my denominator, so I'll write my y cubed in the denominator. And then I tell you as part of my answer, y cannot be 0. That y cannot be 0 part is the part that so many students leave out, and it does make it wrong. Now I also want to say this. If you don't like the cancellation with the exponents and everything, please don't think that you're going to be able to write them all out because some of these get rather large. But you can start with that 3/4 that we found numerically and say y's exponent is greater in the denominator, so put my y in the denominator, and then use the rule for division of exponents. When you divide with a common base, you subtract your exponents. 5 minus 2 is 3. I get the same exact answer either way you want to look at it. Okay? So I don't care which way you want to look at it. If you want to do the subtraction, which is using the rules for exponents, or if you want to use the same cancellation concept as your elementary school fractions, either way works good. Whatever's comfortable for you. Now for a more algebraic example, I have all kinds of polynomials up here. I can't just look at them like I could the 9 and 27 and automatically see the common factors. So how do I begin this? I begin by factoring. In all honesty, no, I don't do my exclusions yet. I do my exclusions on the next line because I'm going to factor that, which is the first step in finding the exclusions. So this is going to be x minus 3x plus 2. And again, you factor it however you factor. And this is x minus 3. Then this is a perfect square trinomial. So that's x plus 3 squared. Now that I have everything factored, let me get a red pen down here. I'm going to come out to the side and tell you x cannot be positive 3 because of that front parentheses, and x cannot be negative 3 because of the back parentheses. So I've got two exclusions that I have to remember to put in as part of my answer. Now, to help us keep things straight, I'm going to change colors as I do my little cancellations. X plus 3 over one of these x plus 3's cancels. X minus 3 over x minus 3 makes a 1 and seems to cancel. X plus 2 and x plus 3, they're not alike, so they're not going to make a 1. They're not going to go away. So my simplified form is x plus 2 over x plus 3, provided that x is not positive or negative 3. And that provision is important because if you look at my answer, there's no reason it couldn't be positive 3. That'll make my denominator be 6. But it would blow up before I ever got started up here at the top. One final example from multiplying. Again, this is algebraic. I can't just look and see the common factors. I have to actually factor it out. So, the top, the numerator, is going to be 3m plus 4 times m minus 2. Again, to double check that, that's negative 6m plus 4m for outer and inner, which is the negative 2. So I feel confident I did that right. 3m plus 2 was already there. In my denominator, this is going to be 3m plus 2, m plus 4. Now double check the outer and inner, make sure we're right. That's 12 and 2 makes 14, so yes. And then 3m plus 4 was already there. Now again, at this stage of the ball game, when I've got everything factored, is where I want to come through and state my exclusions. If you solve each one of those parentheses for cannot equal 0, you end up with negative 2/3, negative 4, and negative 4/3. Okay, so these are my exclusions that are there from the beginning, and now I'm going to go through and see what all I can make go away. Okay, 3m plus 4 divided by 3m plus 4 makes a 1. 3m plus 2 divided by 3m plus 2 makes a 1. I cannot make a 1 out of what's left, so that's going to be my simplified form. M minus 2 over m plus 4, provided that m is not, let me see if I can put these in order, negative 4, negative 4/3, or negative 2/3. Again, 2 of the 3 exclusions went away. So, do your exclusions from the beginning and then carry them all the way to the end. Best of luck.